Thank you, Shaun. So I am recording. And if you all don't know me, my name is Kelsey Johnson. I'm a career coach here at Lambda School. So I may have given a presentation to you before, or you may have seen me in office hours before. I live over here in the EU, and so I work with our EU, UK, and African students very closely. And one of my students happens to be Shaun Ospren, who is facilitating this discussion and invited actually David Flanagan to come speak with us today. So huge thank you to both Shaun and David. It's 5 p.m. where I am, but I believe it's pretty early out there on the West Coast. However, I still voted in the need more coffee category, and I do have my coffee here with me. And just thank you all for being here and I'm really excited to hear David's story, and I'll let Shaun take it away from here.
Thank you, Kelsey. So I'm just going to stop sharing that poll. It's still going to be there if you're at Slido. Just keep going. I'm sure the results are going to be interesting later on. Just a quick run through how we're going to do this. I've got a 2-minute introduction to David. I've got a few questions that he and I talked about through the week. I'm going to read the question. He's going to give us his answer, and then we've got, that'll take about 20 minutes. And then we've got about 20 minutes for Ask Me Anything. That's going to primarily be driven by what's in Slido. So if you do have a question for David, please drop it in Slido. People can vote on it, and we'll bring those up later on. And then we've got some closing questions, about 5 minutes of those, some quickfire questions for David, and about a 3-minute wrap up at the end. So without further ado, let me introduce our guest, David Flanagan. He's been a coder for over 30 years and a professional technical writer for over 20 years. And he's also an experienced teacher, mentor, and manager. He's done everything from helping law firms defend clients against JavaScript patent infringement claims. He's written enough books to fill a bookshelf, and he's built an experimental web browser DOM in pure JavaScript. More recently, he's helped Khan Academy refactor the Python code that supports their website with over 40 million monthly users. He's contributed to the MDN Web Documents project that we all know and love and use all the time, using both Python and React for that. And right now, he's at VMware working on cloud services using Java. He's the author of JavaScript, The Definitive Guide, Java in a Nutshell, The Ruby Programming Language, amongst many other books. And he's just released his latest book, the 7th edition of JavaScript, The Definitive Guide, after a 9-year break. So please join me in welcoming David Flanagan. Thank you so much for being with us today.
It's my pleasure, Shaun.
So here we go. These are the few questions that we've got to kick things off. First one is, you studied computer science at the Massachusetts Institute of Technology and graduated in 1989. Perhaps you could talk us through what led you to study computer science and what excited you about it at the time.
Sure. Let me start by saying I'm happy to be here, everyone. I hope everyone is staying healthy and staying safe, especially those of you in the US, avoiding curfews and the like. And also the 30 years of programming and 20 years of writing were concurrent, not sequential, as you could tell from my 1989 graduation date. I'm beginning to feel old, but I'm not that old. So I started programming in about 1981. It's sort of the dawn of the personal computing era, and was privileged enough that my family bought an early computer in 1981. I actually taught myself to program. Those of you in the US know the now bankrupt chain store Radio Shack. They actually, in the early 80s, sold computers, and had one of the early lines of home computers. And I learned to program by going to the strip mall and going into the Radio Shack, and they had a little computer with a little manual. Like if someone did a good job of documenting basic programming language. And I just stood there, hours on end reading the book and trying it out on the computer, and no one bugged me, let me do it. And it wasn't long after that I realized, oh, I want to be a computer programmer. And I realized at the age of 14, okay, this is my career. And so the decision to study computer science was had already been made, years in advance. So there was really an easy, and it's just the natural thing for me. In my generation of coders, that's, I think, a fairly common story, that people are, going into industry having started as hobbyists. And so, by the time I was getting paid for programming, which started actually around 18, before college, I had 4 years of programming experience, because it was my hobby, and I was geeky enough to spend all my free time doing that sort of thing. So that's a less common experience now. But you will, since you all are trying to get into this industry and will be looking for jobs, be aware that there are going to be some people that you're competing for jobs with who have that kind of background and have been doing it a lot longer than you might think. Anyway, I chose to study computer science because I was just captivated by the joy of computer programming. There's something about, you type your code and you see it. It was, I learned to program on it was far enough into the computer age that it wasn't just a text-based terminal. I wasn't just doing, hacker stuff just green characters on a black screen. This was the TRS-80 color computer, and you could program in BASIC and you could do graphics, and it had colors. And so being able to write code and get an immediate result is just a really fulfilling and gratifying thing. And I hope that most of you have some inkling of that, have experienced some of that just joy of coding in your studies.
Great, thank you. So we're now in 2020, obviously, and a lot has changed since you graduated in 1989. But I imagine there's a few things that have stayed the same as well. And something that I'm interested to know, and I imagine a lot of others are interested to know, is, are there any things that have stayed the same that are surprising to you? Things that you thought maybe wouldn't last, but actually have?
Yeah, let me start just quickly with things that have changed, because it really is, when I stopped to think about it, it really is amazing. That computer I was telling you about, my 1981 computer, had 4 kilobytes of RAM. And the computer I have on my desk now has 8 million times more RAM than the computer I learned to program on. That's really amazing. In the mid 80s, maybe 86 or 87, when I was in college, MIT had a really innovative program to bring high-powered workstations into the university and let students have access to them. It was a project, something called Project Athena, and they got lots of hardware manufacturers to donate computers to them, basically. But the idea is, what can we do if we give all these students and faculty access to state-of-the-art, not just personal computers, but workstations? And they talked about in their blurbs for it, they talked about the 3M computer, and those 3M stood for, I think, 1 megabyte of memory and 1 megapixel. The screens had to be at least 1,000 pixels by 1,000 pixels. Black and white was fine. Just 2 colors was all you needed, but there needed to be 1 million pixels. And then I think the other one was 1 megaflop or something, 1 million floating point operations per second. And those specs were that was huge at the time. And just a few years later, that seemed, it wasn't, by the mid 90s, that seemed just incredibly backwards. So that has changed dramatically, just the sheer scale of computation. What feels to me like it hasn't changed is the basic challenges of software engineering are the same. Programming feels like it did. Debugging feels like it did, many years ago. Dealing with complex software systems is the same today as it is. One of my first professional jobs, I started a consulting company with a friend, and for one job, we were basically just refactoring code. And refactoring X Windows system code from the late 80s feels the same as, refactoring legacy code does today. I mean, legacy code from just 2 or 3 years ago feels the same. We deal with a lot more complexity. We've got much more powerful tools. Our computers are more powerful. Our tool chains are more powerful. The IDEs we use can do all kinds of amazing things. So I think as an industry and as programmers, we're each individually more productive than we were 30 years ago. But the fundamental task, the mental skills you use, and the nature of the work, just dealing with complex code, feels like that has not changed. And I suspect, the people who are the elders for me, the people who started coding in the 60s or something, the people at Bell Labs who created Unix and stuff, I'm guessing they would say the same, that, they could take it back another decade or a decade or two and have similar opinions.
Talking of mental tools, that's kind of a nice segue into the next question that we're going to talk about, which is you've written books that are referenced by hundreds of thousands, maybe even millions of programmers. I don't know how many times people have stolen your PDFs over the internet. But all that knowledge obviously didn't come to you by accident. And just wondered if you'd share with us a little bit about your learning process, the steps that you go through to learn about everything that you write.
Sure. Sorry, I'm still chuckling about the piracy thing. It was, I think, the 6th edition of my book, of the JavaScript book, where I saw it online as a pirated PDF before I even had a copy in my hand. Like before even I got the physical copy, it was out there, and that's discouraging. Tim O'Reilly, the former president of my publisher, his attitude towards that is to treat it as like the sincerest form of flattery is piracy, I guess. That if you've got a piracy problem, then you're in far better shape than most authors ever are. So,
that's
just
a
let
great
it go.
attitude.
So I work hard at that. Okay. Different projects I learn about differently. I try to go when I can to whatever authoritative source is out there. So from the earliest versions, well, let's say for my Java books, Java in a Nutshell, which I started in like late 95. No, anyway, in 1995. When Java first came out, Sun Microsystems had done a pretty good job of documenting it already. There was a specification written. There was coherent Java docs written for the core language. So there was kind of, I needed to translate it and make it into more accessible, but the documentation was already there in good form. So that's an ideal situation, although it makes it a little harder for a book to compete if the docs are good.
To an updated version of your file when it receives a request more than 24 hours.
Thank you for muting. Let's see, for the most recent version of my JavaScript book, I added a lengthy chapter on Node. I have all the old material just on JavaScript with primary focus on the web browser, but this time I wanted to add a lot more about Node as well. And in that case, because Node is kind of controlled more tightly, JavaScript itself in web browsers there's a whole bunch of different web browser vendors, and so no one central authority that's documenting it all. But in Node, it's different, and they've got really good docs. So I can explain it. In my book, I refer people as like, just go look at the Node docs if you need to look things up. For JavaScript itself, from the earliest versions, there wasn't a language specification in the earliest version. So then it's things like you're going to the mailing lists where the developers are chatting. And then once JavaScript is no longer just a Netscape thing going into Netscape, what they call it back then, Communicator, Netscape Navigator. Then then there's Internet Explorer implementing it as well. And then there's mailing lists between the browser vendors, and usually you can join those and listen in. Sometimes it's just reading the source code. If you need to, in an earlier version of my book, I had a chapter about the Jquery Library, which 10 years ago was really important. And so I felt I needed to document it. And for that one, there were probably times where, when I thought there were ambiguities, I would go ahead and look up the source code.
Incredible. Look up the source code. But it does say something that you're saying, read the docs. I mean, we're told often that the docs are good, and now you've heard it from the man himself, read the docs. So leading on from that, and perhaps a little bit more personal now, you started writing these books pretty much as soon as you graduated. I think your first book was published in the early 90s. You graduated in 1989. And I'm just guessing, and I might well be wrong, but there must have been moments when you doubted your abilities, when imposter syndrome struck. Can you talk about that at all? Can you tell us what it was like, how you dealt with it?
I didn't really have imposter syndrome in writing, and you would think I would, but the docs aren't always good. It's kind of a truism that coders generally aren't good writers, or at least it was, back then. And I had studied in college. I'd sort of had a minor in creative writing. So I'd always been fairly interested in writing and decent at it. And so I think I knew a little bit that I had an unusual combination of skills. It also helped that my first books, I was actually hired directly by O'Reilly as a staff writer. So for most of my career, I've just been, self-employed, writing books on my own. But at the very beginning, I was actually getting a paycheck. They hired me as, we want you to write for us. And so that helped a lot. And then to meet the authors of other related books who are in the similar situation. And it's like, oh, he's just like me. So I think it helped to be, to actually be hired to get a job and to like have, I think I took, some writing I had done at work, when I was, student employment coding, but I also did some documentation and used that, and had the job interview, and Tim O'Reilly himself was like, oh yeah, this is really good. So that helped avoid that, that imposter syndrome. I get that more like, public speaking or, yeah, I'm not immune to it, but it didn't happen for me with writing.
That's amazing to know. Listen, my final question before we open it up to the floor, and I've not looked at Slido in this time, so I'm imagining people are still submitting their questions. We'll get to that just after this question. Is this. So most of us on this call are just at the start of our coding journey. And we're obviously keen to avoid the common pitfalls, anything that people who've been this road before can tell us about. And one of the questions we discussed in the lead up to this call is, what's the most common mistake that you see people making when they're learning to code?
Okay, so take my response a little bit with a grain of salt, because, you know, it's been a long time since I learned to code. And, you know, I'm honestly not, since I don't teach coding actively, although I'm fascinated by the challenge of doing it. I think I would enjoy it. I'm not sure. But I haven't actually, you know, I have experience working with like junior colleagues who are, you know, maybe just graduated and are getting used to industry, but aren't at that learning stage. Anyway, I have lots of opinions about it, but I don't know how legit they are. My observation, and this is going back for a long time, is that, you know, people say that if you want to be a writer, you have to write and you have to read. You know, so if you want to be a good writer, read voraciously and write as much as you can. There's something to be said for learning to program. If you want to be a programmer, you've got to write programs. So I would say a common mistake, and this is made worse by just the nature of modern programming practices, is that we jump too quickly from learning the basics of coding into, okay, now you're doing a, you know, you're creating a to-do note application, and you're using this JavaScript framework and this framework on the server, and, you know, you need all these configuration files and these 20 different tools to package everything up and compress everything, and you get overwhelmed with the details, and there's very little focus on where's the actual code. In the US high school system, you know, the advanced placement courses for computer science are done in Java, and you learn to take multiple choice tests and write little snippets of code. But, and this is speaking from personal experience of watching my son go through it, that you come out of that class not really knowing how to write a program. You come out of the class knowing how to write functions. You know, if you do well, you come out of it understanding, you know, you can write little individual snippets, or you can fill in the blanks of, you know, here's, you know, write the missing lines of code in this function. But the actual experience of sitting down and writing a program from start to finish gets lost. And that's in part because our programming tools are so complex. And rather than just saying, you know, let's focus on programming basics, here's some input, produce this output, we're like, okay, we're creating a thin client on the web, and there's this 20 years of APIs that the web has developed, and there's all these frameworks. And so things get so complicated so quickly that it's easy to forget that you also, you need to be, you know, just intimately familiar with if statements and while loops and for loops, just the basic constructs of, here's a problem I need to solve. My brain knows how to translate that into a series of conditionals, loops, and function calls, or, you know, I can use recursion here. Or so I like to advise people to really focus on those core coding skills, or at least not forget about those. Project Euler, that's EULER, the mathematician, is a website. You can Google it. It's a website with programming challenges. They're sort of mathematically oriented programming challenges, but they start out pretty easy. And they're things like, you know, challenge number 2 is what's the sum of all the even Fibonacci numbers less than 4 million? And it tells you how to generate Fibonacci numbers. That's, you know, the 1 + 1 = 2, 1 + 2 = 3, 2 + 3 = 5. So the problem is, write a program that's going to generate Fibonacci numbers up to 4 million, take the ones that are even and add them up. And you'll come up with a number. And on the website, you can type that number in and we'll tell you if you're right or not. So it's a pretty simple exercise, but it's going to force you to, like, okay, you need to know how to do loops. You need to know how to, you know, to me, that sounds like, okay, that's a 5-minute problem. To some of you, that might be like, okay, that, you know, I think I can do that, but doing that problem forces you to test those skills of, how do I translate that description into code on the screen and translate it into loops and conditionals. Anyway, I urge everyone to not neglect that part of programming. You're going to face that with like coding interviews when it comes time to look for a job. People are going to throw coding challenges at you. And it is a truism that I think lots of people get weeded out in the recruiting process, from what I see, because they stumble on some relatively straightforward programming constructs like that. So Project Euler, HackerRank has similar ways you can challenge yourself. I hate the concept of HackerRank, like the extreme competition of whatever. But I think there is something to be said for doing that kind of practice, not to compete against other people in the world, but just to develop those sorts of skills. If you've got time, and I don't really know who does these days, but if to take the time to work on side projects that are just programs you do for joy, that don't have huge frameworks and lots of other setting up tools and configuration files, just doing some programming. I think there's a big leap from going from simple programs like the Project Euler and HackerRank stuff I'm talking about, to then taking it to the next step where you're comfortably writing hundreds of lines of code, or 1,000-line program is sort of a medium-sized program, and that's the kind of thing, when you get that working, it's really satisfying. and my memory is that that's kind of the when your personal projects go to that level, and it's like, yeah, I wrote all 1,000 lines of those code and it works. And that can be things like, a Sudoku solver. That's a non-trivial problem, but and you can just do it with text. You just print, and like, you don't need to have fancy interfaces. If you're doing Python or JavaScript, you can just use console.log or something in JavaScript. You don't need to worry about all the complicated stuff of getting words on the screen, when you can just do it the simple way with like print statements. And then you can really focus on the algorithms and the writing code. Okay, that was kind of long-winded.
It's great, but the summary is write real programs, and I think that's really good advice. And thanks to Mariam and others who've shared some links to things in the chat. Now, the next section of the talk is the Ask Me Anything question. But because of the number of people we've got online, we've asked people to direct their questions to Slido. And the way that Slido works, I was not familiar with it before I joined Lambda School, but I love it. People submit their questions and other people can vote on those questions with a thumbs up. So hopefully we're answering the most interesting questions for the audience first.
Awesome.
I can see all the questions on my screen here. If it's okay with you, rather than just sharing them on the screen, I'm going to read out the question, because I think some of the people on the call don't have video. So I'll just read out the question, and then take as long as you like to answer it. When you're ready for the next one, just let me know and I'll read out the next question. So the first question on the list here is from Gabe, one of the instructors at Lambda School. And his question is, what is, in your opinion, the most misunderstood part of JavaScript? Or, if you prefer, the area of the language requiring the closest attention by a junior developer?
I think promises are one of the trickiest bits. I don't know whether you've all seen those. Promises are the asynchronous programming construct that more modern Java APIs use. Like it used to be that JavaScript was all about asynchronous programming. You're waiting for events, you're listening for events and responding to them, or you're calling functions and passing callback functions to those functions, so your callbacks will be called when a certain event happens. JavaScript programming is all about that. But it was never part of the core language itself until the last decade, I guess. And promises are the core language construct for dealing nicely with asynchronous events. This is where you're using the then function. You know, fetch URL dot then, and then you pass a function to the then function, and the function you pass to then gets invoked when the first part is done, and then it can return something which will get passed to the next function if there's another then in the chain. It's a really elegant way of dealing with asynchronous programming, and if you do it right, it really helps structure your code. And in the simple cases, like in JavaScript, the way that you have your JavaScript code fetch a URL is with a fetch function. That's the modern way to do it. And so you do fetch, and then you do a then, and in the end, the function you pass to the then gets passed a response object, and for that response object, typically you just want the response parsed as JSON, so then you call response.json, or you return response.json, and then you have another then, you pass the function to the next then, and that's what gets the parsed response for the HTTP request you made. So it's fetch.then, and then you have the data you want. And in cases like that, once you've seen it a couple times, it's simple and straightforward, and it can just become automatic and makes everything better. But once you get slightly beyond that level, promises can really mess with your head. And I don't know how to do it better. I think it's fundamentally just a tricky problem to write asynchronous code and think it through. It's an area that I had not seen any really good explanations for, and so I tried hard in the latest edition of my book to dig deep on that and try to give a solid understanding. To present them in, here's the simple use case, and now you need to really dig deep and really struggle to understand them deeply so that you can use them correctly in all cases. So I think they're deceptively simple, but beware and be sure you understand them, because there's lots of subtle ways that you can mess it up.
Thank you for that answer. Our next question is from Anonymous this time, saying, what's your take on the importance of studying data structures and algorithms in pursuing a programming career?
I hate the concept of coding interviews where someone's going to ask you about like sort algorithms. That's sort of the caricature. It's never happened to me, but I imagine it still does happen to people, that they get asked to, like, you know, write a sort program or talk about different sort algorithms. And the reality is that in every programming language, you're just going to use the built-in sort algorithm. There's no way you're ever going to write your own, because really skilled people have invested a ton of time in getting it right. Whatever built-in sort algorithm the language has is going to be way better than anything you do on your own. It's, you know, so undue focus on data structures seems silly. Oh, similarly, like red-black trees, binary trees, like I feel like we're trapped in the 1970s when people start asking about that. Like I have, at work, we're going through a hiring process, and one of my colleagues was putting together some interview questions. And one of the questions she was proposing involved binary trees. And my feedback to her was, you know, I've been doing this for 30 years, and I don't think I've ever needed to implement, well, I've never needed to balance a binary tree. I mean, yes, occasionally I do write tree data structures, but this was one of those, how do you balance a binary tree? Which is one of those classic algorithm or classic data structure / algorithm questions that I think dates back to when we were implementing databases that could be optimized for tape storage. Like you have to do things just so if your only storage is sequential access on a tape rather than a spinning disk, and like, okay, that's really not relevant anymore. So there's a lot of there's a lot of stupid algorithm questions out there, is I guess what I'm saying. And data structure more so. But I think it is still really important to understand the performance implications of the code you write. And so you need to understand that, you know, sets and maps implemented with a hash table are, you know, O1. The big O notation is something you need to understand. That, you know, close to constant time if you're using a hash table based data structure. And, you know, we can look things up. Usually our programming languages give us the tools we need, the built-in data structures, the built-in algorithms. I find it rare to actually have to write that kind of low-level algorithm myself. But it is critical to understand, okay, I'm putting a loop inside of a loop. I need to, when I see a nested loop, I need to understand, wait, am I getting into an O(n squared) situation here? Because if so, and if you don't know what I'm talking about, hopefully you will have a class that talks about big O notation. It's the, when I say n, I mean n is the number of items that your algorithm is processing. And then the big O notation is saying what is the performance of the algorithm. So if I have to sort a list of 10,000 items and my algorithm is O(n squared), that means it's going to take time proportional to 10,000 times 10,000. And the ideal sorting algorithms are, you know, the best sorting algorithms are O(n times log of n. And so it's more like 10,000 times 5, 6, whatever. Like much more efficient than an O(n squared). And the moment you get to O(n squared), things work for small data sets, and then when you deploy in production and things are big, it breaks. And this is like one of the bugs I fixed at Khan Academy was a React bug that was processing a list in a weird way, and it had an O(n squared) thing in there. And it, once the, you know, the list on the screen got to over like 100 items, it crawled to a halt. Literally like, you know, 5 seconds to click a link because it was doing so much processing in the background. And then you have to understand things like, and this is one of my favorite interview questions. In JavaScript, there's a new, relatively new language feature, the spread operator. It's just 3 little dots. And you can use it for copying JavaScript objects into other objects. You're building an object and you have another object that's got some properties that you want to include in the new object. You can just do ... object. And actually, this is the example at Khan Academy, involved a loop where they were adding new items to the object, looping through something and building a new object. And they were, each time through the loop, they were building the object based on the old object and just adding one property to it. But instead of just adding the property to the object, they were copying the object into new object at each step. And what they forgot was those 3 little dots, just ... That right there is a whole loop, because it's copying, you know, n properties from one object into another object. It looks like nothing on your screen, but that's your O(1) right there. And so doing that inside of a loop, I mean, that's your O(n) right there. And so doing it inside of a loop, you're automatically at n squared. And so, you know, this was a professional programmer making that kind of mistake. So it does matter for that kind of competence with performance is super important. The other stuff you may have to deal with for coding interviews, but it's kind of bullshit. But you may need to study up on, you know, it used to be that, you know, Google was always going to ask you about sort questions, I guess. So hopefully you won't have that kind of coding interview experience where someone really thinks it's important to be able to balance a binary tree. But you might, and places like HackerRank are places where you can practice dealing with that kind of obsolete question if you have to.
Thank you. Right, moving on to the next question then from Marianne this time. Is which JavaScript frameworks do you think have the most potential in regards to future job markets? And it's a kind of 2-part question here.
Yeah.
So that's part 1. Part 2 is what's your opinion on Vue?
So I have used React. That's what I did at Khan Academy and a little bit at MDN, and I really like it. But I don't have experience with others. My current job, my team has just taken over the front end work for our product, and that's done with Angular. And I look at it and I was like, what is this? It's like, how do I make heads or tails of this? It feels completely foreign to me. So hopefully that's something over the next month or so I'll have a chance to, I'm actually eager to learn. I know that is a, I know that's a respected framework, and you know, it must be decent or it wouldn't be in such high use. But I'm still at the stage where it's like, I can't make heads or tails of this. And similarly with Vue, I've never used it. So I can't really answer the question well. I do like React. Facebook is a problematic company. The React team just yesterday is, the core React team at Facebook is like getting political and joining walkouts and stuff and asking for better behavior from their company, which I thought was cool of them. Trying to think of whether I have anything more to say about I don't really have my finger on this pulse of this. My impression is that you can't go wrong knowing React. I think that may still be the most popular one. And it's a model that, what resonates with me about React is that, and this goes way back to my days of X Window System user interface toolkits. I've always been a little bit of a front-end person, you know, more concerned with user interface. And you know, back in the 80s, there were toolkits for doing that, and we called them widgets instead of components. But you know, you could write reusable components for X Window System programs that got called widgets. And one of the hardest part about creating these widgets, which I did and I tried to sell them, one of the hardest parts is dealing with incremental changes. Like you've got a widget that displays a graph and someone wants to change the color from red to blue. How do you make that change just that one property and minimize the amount of work that, and back when your computers were 3M computers that, you know, only had a megabyte of memory, you had to worry about doing it efficiently. React just comes in and is like, no, anytime anything changes, we just re-render everything. And then behind the scenes, they work hard to make that really efficient. But as the author of a React component, all you have to be able to do is render your component. Given a set of inputs, you produce the output. You don't worry about these incremental changes. If something changes, you just render it all out. And I loved that. Based on my history of having to deal with user interface components in the 80s, that was a breakthrough to me. Was that, oh yeah, you just, components have these inputs, you produce, essentially you're basically producing a string of HTML for each component. But sometimes those strings of HTML include other components. And it's a nice model. But I can't compare it to other frameworks because I haven't used those. Certainly anyone telling you to learn jQuery is hopelessly dated. You know, don't do that. But my understanding is that React, Angular, and Vue are the three big ones. But React's the only one I can talk about.
Fantastic. Thank you for that answer. So we're coming up towards the end of the interview now. I think we've probably got time for another 2, maybe 3 questions. So I just want to encourage people.
I can go over if you want.
That's very kind.
I've been kind of long-winded, so if people want to keep listening.
Yeah, no, I think we've still got near enough 170 people on the call. So if you're prepared to go over by a few minutes, just let me know when you want to start wrapping up.
Okay.
I will keep asking questions. Audience, please keep voting on the questions because this allows me to ask the most interesting questions to David. So the next one, I kind of put there as a kind of throwaway because I was a little concerned at the start of this meeting that no one had put any questions on there. And it's been voted up and up and up. So I've read that coding is 90% fixing bugs and 10% writing new bugs. The question is, does that change as you get more experienced?
I would like to think that you write fewer bugs as time goes on, but the job of software engineering, so not long ago, I was going on and on about how you really need to like double down on just writing non-trivial, learning your loops and your conditionals and writing programs on your own. And the truth is that in the real world, the jobs out there in software engineering, it's a rare pleasure when I get to just sit down and write a big chunk of code. It is true that the day-to-day work of software engineering typically is you join a team that already has a big code base. They've got 100,000 lines of code to do something, and you're joining the team to add incremental new features and to fix bugs as they occur. And so in that sense, it's totally common that 90% of your work would be finding bugs in other people's code and fixing them, or adding the product manager shows you a screenshot and it's like, we need this new feature, or UX designer hopefully doesn't just show you a screenshot, shows you a nice mock-up in Figma, and you work out how to do that. But you're not like sitting down and writing big chunks of code. You're futzing around with the stuff around the edges. So that, I think, is true, that yeah, a lot of time spent fixing bugs or otherwise incrementally making improvements to existing code. And the 10% writing new bugs is a good joke. And it's funny because it's kind of true, because we like to laugh at ourselves. But with practice, it does get, the coolest experience is writing code and then trying it out and have it work on the first time. And that doesn't happen often, even for me, but I think it does happen maybe a little bit more often with practice.
Thank you. So Gabe is our next question author, and his question for you is, how would you sell JavaScript to a complete newbie in programming over other options like strongly typed languages, for example? I'm
not sure I would try to sell it because it's such a fixture. It's not like we have much choice. It's the programming language of the web. And so you're gonna kind of have to learn it regardless. I don't want to be that cynical about it though. Like, I do enjoy it as a language. There is, the untyped nature is nice for quick stuff. And, with any language, you sort of learn the idioms, like the good practices and the bad practices, and, you pick those up over time. And with an untyped language, it's easy to write bad code. But with practice, you can avoid those pitfalls, I think. Plenty of people who are adding types to JavaScript, either using TypeScript or using Flow in addition to TypeScript, using Flow as an add-on to JavaScript so that you get that type safety. And I've actually really, when I have done that, it's not uncommon to see React projects, for example, that also adopt Flow. And I think more and more people are going to TypeScript, but my experience is with Flow. But I think they're essentially, there's syntactic differences, minor ones, but the experience is essentially the same. And that gives you the discipline of a typed language with JavaScript. And I write about that a little bit in the final chapter of my book. And my recommendation to new JavaScript programmers is just master JavaScript as it is first. And then when you're ready for the next level challenge, start adding types, because that opens up a whole new world. Having just started a job where my primary coding is in Java now, I've been reminded of, oh yeah, this is nice. Having all those types, there is something nice about it. Like an IDE, when everything is typed, can pretty much just guess what you're going to type next because it knows the type of the object your cursor is on right now. And so you just start typing the first few letters of a method name or something, and it knows what you want. And so when things are typed, the tools become a lot more powerful. And your confidence of not messing something up increases because there's so many things the compiler would catch for you if you do it wrong. So what is the magic? You know, JavaScript. Some people hate JavaScript. Some people just like to make fun of it because it does have some weird bits. But I find it a really productive language. When I need to write a little utility, a little command line utility, I try to avoid shell script languages as much as I can. And if I need to write a little tool to copy some files or make a scripted HTTP request or something, I go straight to Node. I don't even do Python. For me, JavaScript is my language of choice for things like that. But yeah, I don't think I'm doing a great job of selling it here. But it's one of those things where you do just have to learn it because it's the web. And yeah, everyone's got to know at least a little bit of JavaScript, it seems like, into this day and age.
That's a good answer. So the next question comes from Jay Leach. And his question for you is, what skills or concepts do you think are key to bridging the gap as a junior level JavaScript developer versus intermediate?
Oh, bridging the gap from, like, when do you, I think, I don't know that it's particular skills or concepts. I think the difference between a junior developer and, rising up through, getting promotions to more senior isn't necessarily, particular concepts or skills. It's developing some independence. It's just gaining that experience of working with your team, being comfortable with coding, being able to work more independently. So I think it's more just getting that career experience, rather than any particular, like, I wouldn't say that, to use my example previously of, oh, promises are the trickiest bit. Like, I wouldn't, and it used to be, 10 or 15 years ago, the tricky thing was you have to understand closures or you're not a real JavaScript programmer. That separates the men from the boys, to use probably sexist old phrase. So it used to be that, some people have gatekeeping ideas that, oh, you need to understand this to be a real programmer. And I don't think there's anything like that. Like, you could be someone straight out of, you could be someone who's a whiz at those coding interview style questions, and you've really studied up on your promises, and your closures, and you can answer all those tricky questions. But that doesn't mean you're experienced with working on a team, communicating well, working on a shared code base, developing, understanding how to prioritize, how to triage bugs. And I mean, there's so many other skills that go into being an effective software engineer than just your, particular concepts or tools or programming. So to answer that question, I think it's not the raw technology. It's the on-the-job experience that makes the difference. Focus on your communication skills, Like that's real important. If you can compose coherent emails, especially now when we're all working at home, you know, ask questions, communicate clearly, be the person on the team who sends the long emails. I think that's a really valuable thing to do. You know, participate actively in the Slack channels. That's as important as, I mean, given a baseline of competent coding skills, what you layer upon that is communicating clearly, being proactive about getting bugs fixed, or, you know, filing a good bug report is a really important software engineering skill that, you know, comes with practice. Okay, I'll stop there.
Fantastic. Listen, we're coming up to 2 minutes to the hour, so we want to be respectful of your time.
Yeah, no, let's take another 2 or 3 questions.
Sure. So we'll take another 3 questions then,
Okay.
and then we'll start to wrap up. Really appreciate you spending the extra time with us. Thank you so much. So Amin has a question here, which links nicely to the book that you've just recently released. So his question is, do you recommend reading JavaScript, the definitive guide, front to back, or using it as a reference, resource for referencing?
I should probably have like done some user studies and had focus groups and stuff of people who actually have faced the book. I want to believe that if you make the time to sit down and study it and take the time to work through it front to back, that you'll get a lot of benefits out of that. But I don't know, I haven't like asked readers like, you know, did you actually do this and what did you think? The new version is only this thick, and it used to be, you know, quite a bit thicker because I've taken out the reference material because online is so much better. So it's not quite as daunting as it used to be. But the first 5 chapters are kind of a slog. And then even the next couple of chapters after that are there's a lot of information in there, but like chapter 4 and chapter 5 are, chapter 4 is, here's every operator in the language. This is more than you ever thought you wanted to know about multiplication. And here's everything you need to know about shifting bits to the left. And then here's a couple paragraphs about shifting bits to the right. So a question like that isn't going to, I mean, you're not going to need to read that chapter and like memorize all the details. That is more of a reference chapter. But you do really need to understand the Boolean operators, you know, the ampersand and vertical bar operator. And, you know, that chapter goes on at length. So the chapters are ordered sequentially. That there's a lot of referencing back and forth because nothing is sequential really in programming. You got to kind of understand it all before you can understand any bit of it. It's a hard problem. So some of the chapters are a bit of a slog, and you don't need to read every single section before moving on. But I want to believe that if you invest the time to read it front to back, skipping some sections to come back to later as needed, you know, don't let yourself get bogged down in it and force yourself to read it all. But I think that you'll benefit from you know, work through it, maybe a quick first pass, and then go back to the parts that seem most relevant. Chapters 4 and 5. Oh, sorry. Chapter 5 is like chapter 4, but instead of being about every single operator, it's about every single statement, and lots of details. Like, okay, you maybe don't need 2 pages on the while loop, but maybe you haven't seen a while loop in any other language before, and you do want all that detail. So yeah. Try it and let me know how it goes if you read it front to back. Thanks for asking.
Thank you. So our second to last question then comes from Dom, and it's a short one. Is programming more like math or more like writing?
Oh, I love that. Those are 2 of my favorite things. When I don't often interview people for jobs. I've never been a hiring manager, but when I do interview people, I do like to try to gauge a little bit of their mathematical understanding, because I think that's a pretty valuable skill. I don't know that I would say that programming is that much like math. Okay, people who go into like theoretical computer science, if you go get a degree in computer science and then go on to graduate school in computer science, there are the people for whom it really is math. It's, you know, theoretical computer science is a branch of applied mathematics, and has been for 50 years or whatever. But leaving those people aside, because that's not the real world of software engineering. I think it's important to have, to be numerate and comfortable with math. But I can't remember when I've used anything more than, okay, the last time I remember having to do some math while programming, other than just being comfortable with numbers, that's important. When I was working at Mozilla on the Firefox OS project, we were creating a mobile phone operating system written in JavaScript. It failed in the market and is still, its remnants are out there as in the form of KaiOS, if any of you have heard of that brand. You know, it's not Android, it's not iPhone, it's JavaScript on a phone. Anyway, one of the, you know, for scrolling, when I was in charge of the gallery, the photo gallery app, and so you're swiping sideways. I had to implement that. Like, it's raw JavaScript event handlers. There's a touch, and then you track the touch, and then when you lift your finger off, you want the photo to coast a little bit. And so I actually tried to remember some physics and some math, and was like, okay, as the finger's moving at this velocity and, you know, pixels per millisecond, and when they lift their finger off, what's the momentum of the photograph and how far would it coast, assuming, you know, whatever. I didn't really remember my physics or my math that much, but I think there might have been some kind of like integral in there. And it's like, okay, maybe I did some calculus. I winged it more or less, but it was vaguely informed by mathematical understanding of some physics and some math that may have involved loose memories of calculus. Machine learning, people who are doing neural nets, if you've read any of the theory behind that, it very quickly gets into multivariate calculus, because the theory of training a neural network involves partial derivatives, and that very quickly goes over my head. So people who do that probably need to remember math. But again, it's not necessarily a practical skill, but you have to have that conceptual understanding of seeing it once or twice before. But it doesn't feel to me like programming is about math. It requires rigorous logical thinking. So you have to be the kind of person who likes math. Like, I think those skill sets go well together. I think if you would make a good lawyer, you would probably also make a good coder. Like, just that kind of analytical thinking skill. But then the part of the question I'm excited about is it more like writing? Because a hypothesis I've been forming recently, thinking about, you know, what makes a good programmer? Why do we find so much bad code out there? And I'm working on kind of a legacy code base now, where lots of code written by people who aren't on the team anymore, and I look at it and I cringe, and it's like, you know, how did this happen? How did we get so much poor code, poor and undocumented code in our code base that now we have to deal with? So you probably hear lots of people telling you to comment your code. I hope that your instructors are making you write comments and grading you on it. Because I think it's an important discipline, and in some teams, in some parts of the field, it's almost like it's something we don't do anymore. There are people who believe that if you've got test cases, then you don't need to comment your code because your code is self-documenting, or the test cases are like test cases can be a specification for what your code's supposed to do, but anyway, I'm a big fan as a writer, you know, maybe I'm biased, but I'm a big fan of putting documentation in your code. And people will tell you, it's not, you know, so one idea about documentation is it's for future people who have to deal with your code, like future coders who have to maintain your code. And I'm feeling that right now. Like there's plenty of code I have to deal with that I would love it if I can read line by line or chunk of code by chunk of code. I can figure out what it's doing. But right up at the top of each file or, you know, each method in a Java class, like if you told me why this function is here in the first place or what it's doing in the bigger picture, that would make my life so much easier. So that's one important reason to write it. And then other people say, oh, don't even think about future other people maintaining your code. You're writing comments for you a month from now when you have to come back to it and look at and fix bugs in it. And that's really true also. Like I find that when I'm writing a big chunk of new code, the hairy bits, or if it's not uncommon for me to write 100 lines of comment at the top of a new Java class if it's doing something complicated, because there's so much context to explain. And I found that really valuable. But what I'm getting around to is the other reason to comment your code, and this is my hypothesis, isn't for other programmers. It's not for you in the future. It's for you right now. That by writing out your thinking in plain sentences, you're going to improve your thinking. That if you've got some tricky algorithm to figure out, you're trying to compute the Fibonacci numbers less than 4 million and find the even ones and add them up. If you can take that problem statement, express it in the form of a code comment in a couple of sentences, or as you're writing your code, you add a few sentences showing your progress, it's going to clarify your thinking and improve your code right there in the moment, just by the act of commenting. Because it's kind of like writing a test. Writing tests basically means you're writing the same code twice, and you've got two versions of it independently written, and they both have to agree. And if you add comments, then you're doing it a third time. One time is just in English, and it's making you think through your work a second time as you're doing it in a different form, so you're more likely to see errors, I think. And I would love to test that. I've been thinking that there ought to be some way, VMware is a pretty big company. There ought to be, and the recruiters at VMware do some kind of manual screen. I think before you can actually talk to anyone when you apply for a job, you have to pass an online test at HackerRank or something. And I would love to do an experiment where we actually have two different cohorts. Some people are told on their automated test, you're going to be graded on the comments, and some people aren't told that. And just to see whether the people who were forced to add comments produce better code. Anyway, that's an idea that's been in my head, and I've liked talking about it. So I sort of hijacked that question.
It's a great idea.
I think it's a little bit more like writing than like math, but both of those skills will make you better coders.
Right, so this is our last question then before we wrap up. And there's two pretty highly voted questions here that I think are kind of along the same lines. So if you'll permit me, I'm just going to combine them, and then we'll see where you take the answer. So the first question comes from Anonymous, and the question they're asking is, how do you think about managing complexity in software? Are there any books that you recommend? And the second question comes from Andy, and his question is, how do you train your brain to think logically when it comes to code challenges? And I'm kind of linking that to complexity. So yeah, over to you.
Those are both good questions. There probably are books about that, but I'm not aware of them. I am actually a kind of slow reader, so I don't actually read many books in this industry, and maybe that's just because I've been doing it for so long. I haven't felt the need. And how do you train your brain? I think, I mean, my basic answer is going to be, you know, you learn it by doing it. And, you know, part of becoming a software engineer is working on projects till 3 in the morning because you can't figure out the bug. It's just not working. It's just not working. And finally you spot the, you know, the missing semicolon or whatever it was. You know, obviously it's something more than that. But part of it is just putting in the time and learning from, you know, by making the rookie mistakes that everyone makes. And that kind of logical thinking, I don't think it's inherent to us. I mean, maybe, yeah, I think it's something that comes with practice. So put in the time and, you know, do the practice problems and you know, there are, you know, the more general question of just dealing with complexity in software engineering. I think there's a whole literature about that of, you know, just systems thinking, and in engineering disciplines in general, it's kind of all about containing complexity and modularizing things so that we can think about complex systems as as simpler systems. And yeah, I'm sorry, I don't have any good references to recommend, but it's a hard problem. I mean, writing reusable modular software is something that software engineering has been struggling with since the beginning, really. And some of it is fashions, you know, programming with, what do they call it? The Gang of Four book, the software patterns, was a big thing 20 years ago, and it still is to some extent, I think, but that's sort of faded a little bit. And, you know, object-oriented, stronger, weaker, that kind of comes and goes in and out of favor. There's different ways of, it's all the same problem that we've been dealing with the whole time. And yeah, I don't have a good answer for this one. Sorry.
That's great. Listen, thank you. So I'm going to wrap up the Ask Me Anything section here, and we're going to start wrapping up the whole talk. We've got 3 quickfire questions for you. Okay. Very short answers, or as long as you like, doesn't matter. But the first one is, if you were to write a book about anything other than programming, what would it be?
I used to want to write fiction. You know, I mentioned that I did do a concentration in creative writing, and I used to think I would, you know, write a science fiction book or something. I still think about that sometime, but I don't think it's ever going to happen. And I'm no longer convinced it would be any good. I have wondered, and this doesn't actually answer your question, but I have wondered whether it's possible to write a book about coding and the nature of coding and software engineering for a general audience. Not for people who are doing it professionally, but for people who are just kind of curious about, hey, the tech industry is taking over the world. What's this all about? You know, what does it mean to be a coder? So that's kind of about programming. I don't know that. So most of my books, until this most recent book, I was self-employed, and my full-time job was writing books. Now that I have a full-time programming job, there's a lot less time to write books, and so, you know, that's probably not going to happen. But it still does intrigue me to think about whether coding can be explained in a way that would actually interest non-coders.
Well, I'm sure I'm not the only coder who would like to read that book as well. So maybe don't shelve that idea right away. Second quickfire question then, other than your own, is there any book that you recommend frequently to others?
I do, and I had it on my desk because I knew you were going to ask that. Effective Java by Josh Block. I don't know if Java is part of your curriculum, but it's one of those languages that you don't have to know, but is likely you'll encounter it at some point in your career. Joshua Block was the engineer at Sun Microsystems who's primarily responsible for the collections library in Java, which was really important when it was introduced and is still really important. He modeled this book on, I think it was like Effective C or Effective C++ or something, and I haven't read those books, but he tried to take a similar approach, and it's just full of good advice, and I recommend it to my colleagues and stuff. So yeah, if you come anywhere near Java, it's not useful if you're not doing Java, but if you're going to do any Java programming, once you've learned the language, it's a must read.
Fantastic, thank you. The final question then, what's the most exciting tool or technology that you've tried recently?
I like the Go programming language, but I haven't had the opportunity to write any substantial code in it yet. So I'm looking forward to that. The biggest new tool for me is learning to use IDEs after many, many years. Like I started coding in the 80s and learned Emacs as my editor. And that's a very old style editor, but it can do everything. And my fingers learned the keystrokes for Emacs, and I was never willing to use anything else. But finally, I started using Java again, and Java is such an IDE-centric language that I found that there were Emacs key bindings for IntelliJ. And man, I was been missing out. Like it really is. Anyway, I spent a long time sort of looking down my nose. I hadn't tried IDEs since like the 90s when they were kind of crappy. But now with a really high-powered laptop and IDE, I'm sure you all already know this, but I only just learned it a few months ago when I picked that up. So, so yeah, that's our software tools can be pretty amazing when they work well.
Great. Well, listen, I'm going to wrap up now. Start by saying thank you so much, but also want to let everyone on the call know and everyone who watches the recording later that your latest book, the 7th edition of JavaScript, The Definitive Guide, is out now, and it's available everywhere. Plus, wherever you are in the world, I believe you can get a free 10-day preview by registering for a trial account with O'Reilly Online Learning. Is that correct? Yeah,
I think it is. O'Reilly's does a subscription model, and if it might be a perfect fit for those of you, and I honestly don't know how much it costs, but while you're on this learning journey that you're on, it's basically book rental, like any book, and not just O'Reilly books. I think they partner with a bunch of other technical booksellers. I know some companies I've worked for have the option of getting subscriptions to that, where it's basically like your personal library. Any book you want, you can just start reading it in your web browser for whatever the monthly rate is.
Fantastic. So there you go. Free 10-day preview to that. It might well be worth having a look at that. And if people on this call want to find out more about you and your work, where's the best place to connect with you or see what you've done?
In preparation for the book coming out, I did start blogging again after a long hiatus. So I've got a vanity domain, davidflanagan.com. I have a blog there. We'll see whether I actually keep any content up there. There's a little bit about the book there now. You can find me on Twitter. I'm __ David Flanagan on Twitter, and that's kind of my online presence. Between those two, that's about it.
Fantastic. And then finally, any final thoughts or advice you'd like to leave us with before we end the call?
Just, write code. That's my biggest advice. Like if you're going to be programmers, make the time to do programming. And don't get so caught up in the ins and outs of, each framework or each, you know, don't sweat the config file so much. That'll get sorted. You know, write the code.
It's very encouraging to hear that. I do sweat the config file, and maybe I won't worry about it so much in the future. Listen, David, thank you. It's been an honor and a pleasure to have you on, and you've gone way over time. So thank you so much for that. On behalf of everyone on the call and Lambda School, really appreciate your time. Thank you so much.
You're welcome. Good luck, everyone.
Thank you.
Thank you.
Bye.
Bye.
Practice, practice, practice.